The most expensive trap in the history of technology warfare costs $200 million per day to maintain, and America is paying it willingly. Here is the paradox that should be keeping every technology strategist in Washington awake. The United States has deployed the most aggressive export control regime in semiconductor history, restricting advanced chip manufacturing equipment, design software, and finished processors from reaching Chinese customers. The policy is designed to slow China's AI and military technology development by denying access to the tools of frontier chip production. The policy is working exactly as intended, and it is simultaneously accelerating the precise strategic vulnerability that it was designed to prevent. The mechanism operates through Taiwan, not through Chinese action in Taiwan, through the structure of American dependency on Taiwan that the export control regime has made more acute, more concentrated, and more strategically precarious with every passing quarter. China does not need to produce advanced semiconductors to win the semiconductor war. It needs to maintain the credibility of its threat to Taiwan's production capacity at a cost-exchange ratio that makes American strategic position unsustainable. At $200 million per day in military deterrence expenditure, the arithmetic is not in Washington's favor. Let that sink in for a moment, then follow the money through every link in the chain. Chapter 1. The concentration that created the vulnerability. The Taiwan Semiconductor Manufacturing Company does not merely dominate advanced chip production. It occupies a position in the global technology supply chain that has no historical precedent in its combination of technical superiority, geographic concentration, and strategic irreplaceability. TSMC's market share in chips at 7-nanometer precision or below, the chips that power artificial intelligence systems, advanced smartphones, high-performance computing, and the most sophisticated defense electronics, stands at approximately 90% of global production. Not 40%, not 60%, 90%. The next closest competitor is Samsung at approximately 8%, with Intel's foundry ambitions at 2% and growing. China's SMIC at approximately 0. 3% of sub-7-nanometer capacity despite years of intensive investment. Now, apply that concentration to American defense industrial dependency. The F-35 Joint Strike Fighter program requires chips manufactured at 7-nanometer precision or below for its advanced avionics, radar processing, and electronic warfare systems. The Joint All-Domain Command and Control Architecture, the network that American military strategy depends upon to coordinate across services in peer-competitor conflict, requires advanced chip processing that has no domestic alternative. Lockheed Martin, Raytheon, Northrop Grumman, and General Dynamics collectively identified in their 2024 annual reports a dependency on TSMC-produced semiconductors for more than 60 individual defense programs. If TSMC's production capacity were disrupted by conflict, by blockade, by the credible threat of either, the American defense industrial base would face an equipment production crisis with no domestic substitution available at any price. The CHIPS Act is building domestic alternatives. Arizona, Ohio, and New York will eventually host advanced fabrication facilities. Eventually. The leading timeline for TSMC's Arizona facility to reach volume production of 3-nanometer chips is 2028 at the earliest. The factories that the Chinese People's Liberation Army is modernizing are being equipped today with weapon systems designed for today's threat environment with semiconductor content that matters now. This is the trap. Not a trap that China set deliberately. A trap that American technology industrial policy built over 30 years of rational commercial decision-making, one outsourcing contract at a time, until the concentration reached a level that created strategic vulnerability independent of anyone's intention. Chapter 2. The $200 million daily arithmetic. Now examine the cost structure that defines the strategic trap's parameters. The United States maintains its Taiwan deterrence architecture through overlapping military commitments. The 7th Fleet forward presence, centered on carrier strike groups operating in the Western Pacific, costs approximately $5 billion annually to maintain at current operational tempo. The Patriot and THAAD missile defense deployments in Japan, South Korea, and Guam add to $1 billion annually. The enhanced intelligence, surveillance, and reconnaissance posture focused on PLA movements across the Taiwan Strait costs approximately $4 billion annually in dedicated assets. Enhanced arms sales to Taiwan, $19 billion in approved sales since 2021, represent capital expenditure rather than operating costs but generate ongoing sustainment commitments. The aggregate operating cost of the Taiwan deterrence architecture, including proportional allocation of Pacific Command overhead, reaches approximately $73 billion annually. Divide by 365 days. You arrive at $200 million per day. Thus, the recurring cost of maintaining the deterrence posture that protects the single production facility that American technology and defense industrial production depends upon. China's cost for maintaining the coercive pressure that necessitates this deterrence spending is considerably lower. PLA exercises in the Taiwan Strait consume operational budgets drawn from a defense spending base of $225 billion annually, less than 1/3 of American defense spending. The cost-exchange ratio of maintaining deterrence versus threatening the deterrence-requiring asset is asymmetric in China's favor. Beijing can sustain coercive pressure on Taiwan at a fraction of the cost that Washington incurs to deter that pressure. This is the operational financial logic of the semiconductor trap. Not that China will necessarily invade Taiwan, but that China can impose on the United States a $200 million daily operating cost for as long as the strategic dependency on Taiwan's semiconductor production continues, and that this operating cost compounds alongside the operational risks that make the dependency strategically untenable. Chapter 3. The Export Control Paradox. Here is where the policy designed to reduce the vulnerability has instead intensified it. The American semiconductor export control regime expanded significantly in October 2022, October 2023, and April 2024, restricts Chinese access to advanced chips, chip manufacturing equipment, and the design software necessary for frontier semiconductor development. The stated objective is to prevent China from developing the AI processing capacity needed to advance its military systems and to slow China's progress towards semiconductor self-sufficiency at the most advanced nodes. The controls are achieving their stated objectives. China's progress in sub-7 nm chip production has been materially slowed. Huawei's Kirin 9000S chip, announced in 2023 as evidence of Chinese semiconductor advancement, was manufactured at SMIC's 7 nm equivalent process through techniques that circumvented some export control restrictions, but demonstrated the difficulty of sustained advanced production without access to ASML extreme ultraviolet lithography. The chip performed adequately, but the production costs and yield rates that SMIC achieved indicated a manufacturing process 3 to 4 times more expensive than TSMC's equivalent production. So the export controls are working. Now examine what the controls are simultaneously doing to TSMC's strategic position. By restricting Chinese semiconductor access, the export control regime has accelerated Chinese investment in TSMC alternative capabilities with a focus and budget commitment that would not exist without the restrictions. Before the export controls, China's semiconductor self-sufficiency investment was ambitious but distributed across multiple technology priorities. After the export controls, semiconductor self-sufficiency became the single most important strategic industrial objective of the Chinese state. Receiving budget allocations estimated at $150 billion through 2027, the full attention of CCP leadership and the directed research resources of China's most capable technical institutions. The controls also increased TSMC's indispensability to American technology companies because the restriction of Chinese supply alternatives eliminated the market competition that might otherwise have driven American companies to develop or qualify alternative suppliers. When Chinese foundries were theoretically available as backup supply, even at inferior specifications, American chip designers maintained contingency planning capacity. After the restrictions, the contingency disappeared. TSMC's 90% market share in advanced logic is not decreasing under the export control regime. It is increasing because the controls eliminated the one developing competitive threat to TSMC's position. Chapter 4: The TSMC Arizona Mirage. Washington's answer to the concentration problem is TSMC Arizona, the $40 billion investment that the CHIPS Act catalyzed, representing the most significant American semiconductor manufacturing investment in a generation. The investment is real. The construction is proceeding. The economic argument for Arizona-based production, proximity to American defense customers, supply chain security, workforce development in American manufacturing, this is coherent. The timeline is the problem. TSMC's Arizona Fab 21 will produce chips at 4nm precision when it enters volume production, targeted for 2025. Fab 21's second phase, targeting 2nm or 3nm production, will not reach volume production until 2028 at the earliest. For context, TSMC's Taiwan facilities are currently producing at 2nm and moving toward 4nm development for 2026 delivery. The Arizona facility, even on the most optimistic timeline, will be approximately 2 technology generations behind TSMC's Taiwan production capability when it enters volume production. The workforce challenge is equally significant and less discussed in public reporting. TSMC has been transparent in disclosures to its investors about the cultural and operational difficulties of replicating Taiwanese manufacturing excellence in American facilities. The yield rates, the percentage of manufactured chips that meet performance specifications at the Arizona facility during initial production were reported to be below Taiwan facility equivalents, requiring additional engineering support from Taiwanese personnel that created immigration, technology transfer, and operational management complications. The Arizona facility is valuable. It is not a solution to the strategic concentration problem on any timeline relevant to the current geopolitical environment. The facilities will not be fully operational at meaningful scale before 2028. The 2-generation technology gap will persist unless American investment accelerates dramatically beyond current CHIPS Act commitments. And the yield and workforce challenges indicate that replicating TSMC's Taiwan production excellence in an American context requires institutional knowledge transfer that cannot be accomplished on an emergency timeline. Chapter 5: The Strategic Geometry. Understand the geometry of the position this creates. The United States is committed to defending Taiwan's territorial integrity through a combination of formal arms sales, informal security commitments, and military deterrence posture. That commitment rests on a combination of values: democracy, rule of law, self-determination, and interests. The interest that is rarely stated explicitly, but that drives the operational defense planning, is the semiconductor interest. A Taiwan under Beijing's political control or subject to Beijing's production decisions is a Taiwan that can no longer function as the world's indispensable semiconductor manufacturer for the American economy and defense industrial base. China's strategic position benefits from the following structure. It can credibly threaten the asset that America's technology and defense industrial production depends upon, at a cost to China that is manageable, at a cost to America that is $200 million per day and rising. The threat does not require execution. The credibility of the threat is sufficient to impose the costs and constrain American strategic flexibility. The $200 million daily figure is not the ceiling. As PLA modernization continues, as Chinese naval capability expands, and as the Chinese Air Force acquires more sophisticated platforms for power projection across the Taiwan Strait, the deterrence cost increases proportionally. The Congressional Budget Office's 2024 analysis of Pacific deterrence cost projects a 34% increase in required deterrence expenditure through 2030 under current PLA development trajectories. $200 million per day today becomes $268 million per day by 2030. Against this cost structure, the American response is building semiconductor fabrication capacity in Arizona that will be 2 technology generations behind TSMC Taiwan when it enters production, while funding TSMC Taiwan's defense with increasing expenditure each year. The trap is not that either element of this strategy is irrational in isolation. The trap is that both elements together, increasing defense expenditure to protect a concentration while building domestic alternatives too slowly to reduce the concentration, sustain the strategic vulnerability indefinitely. China's winning condition in the semiconductor competition is not operational. It is financial and temporal. Beijing does not need to produce advanced chips to win. It needs the American deterrence cost to remain high, the domestic alternative build-out to remain slow, and the strategic dependency on TSMC to remain structurally intact for long enough that the cost asymmetry shifts the political calculus in ways that create the outcomes Beijing seeks without requiring the military risks that Taiwan invasion would impose. At $200 million per day, with the meter running every day that the alternatives remain under construction, the geometry of the trap is precise. The United States built the most powerful semiconductor alliance in history to counter Chinese technological ambition. In doing so, it concentrated that alliance's production in a single geography, created a deterrence cost structure that compounds annually, and deployed the export control regime that made China's self-sufficiency investment more urgent and better funded than anything that would have existed without the restriction. The $200 million semiconductor trap did not require a Chinese architect. It required American commercial decisions, strategic constraints, and policy choices that each made sense individually and that produced, collectively, the most expensive strategic dependency in the history of technology competition. That is the mechanism, and the clock runs at $200 million a day.